Hello everyone, welcome back. So in this video we are going to understand the Leetcode problem number 2452. It is saying that we have to find the words within two edits of a dictionary, right? So imagine you are allowed to change just two characters from a word, right? Let's think that we will take any word, right? And from the query we can say that the query contains many words, as you can see here, right? So I'm saying just imagine that you are allowed to change two characters, right? Two characters from a word, right? So can you make it a match with dictionary word? So any word we can take, let's suppose this word we will take, and we will convert into this by changing two characters. Understand? Right? Sounds like easy, correct? But the most people overcomplicate this problem. Let me show you the simple trick that track it, and you will crack this problem or solution, you can say, very instantly. Okay, so first let me clean this. Okay, now let's think about the question first. The question says that you are given two things, queries and dictionaries you have given, right? So queries contains, as you can see here, is a list of words where you want to check, right? And dictionary contains the valid words. So if you will choose any of these, so first you have to remove two characters and you will check is it matching this or not. If it matching, we will put that word into the result set. This is a very simple thing, right? So your task is very simple. For each queries, right? For each queries means for each query element, we have to check if we can convert it into the dictionary, any dictionary words, right? Any of these, using the at most two characters changes. Okay, this is a very important rule that we should understand. So what it is saying that all words are the same length. Okay, so this is not an insert or delete. Only you will do is a replace operation. Okay, only replace. You cannot do not insert or delete. Only you have to do replace. Clear, guys? So let's understand the problem, right? So let's think that the queries we have given and the words we have given. Let's take the case one. In the case one, what we have is we have word. So word vs, let's suppose we'll take the wood, right? We'll take wood from here and word from here. Okay, now compare character by character. So let's suppose if I'll compare this one, this matches, this also matches, this is not matching, right? But this is matching, correct? So there is one letter R. If we'll convert into O, it means it should work, right? Because there is only one difference, R is not equal to O, right? So total valid difference we can say is 1, right? And which is valid. If the difference or mismatch we can say is 1, then we will say it is valid. Okay, let's take, because number of character change we can do by how many is 2, that is why I'm saying valid is 1. Okay, now take case 2 where we have note. As you can see here, we want to convert into, let's say, joke. Okay, or we'll not take with the joke, first check with the word only. Okay, so we'll check with vs would, we can say, right? Not word, it's would. Compare this, not matching. Compare this, matching, it's fine. Compare this, it's not matching. Compare this, it's not matching, right? Means if you have observed, it is not matching many places, right? It means there is too many difference, we can say, or mismatch. Let's suppose in this case three mismatches there. It means it's not valid. Okay, so if it is not valid, so it will not work, right? So we will go with the next character, that is joke. So now we'll check the note with the joke, right? So if we'll convert the very first letter N with J and T with this the T with what you call K, right? It means there is two mismatch, right? As we can see, this and this one, and this is two, right? Means total how many mismatches are there? Two mismatches be found, and which is valid, because maximum two correct we can change. Like this we have to check, and similarly we will check with the ant, right? And we'll compare this, right? You will say that there is no difference, we need that, right? Like that you will keep checking the value and you will see the output, right? You can see the examples also we have given here in the, you can pause this and you can go through this, right? So when you're changing, right, you will see that it's matching with the words. Okay, so this is exactly we will do in this problem statement, guys. We can work on this, right? So very first thing we should understand is this problem is basically a two pointer style. We will use two pointer. I hope you knows. In the two pointers we need two pointer. The concept says, right, as the problem says, two pointer means two pointer, and then we'll do the compare. Let's say the very first we'll take the word, right, we have seen, and then we'll use would, right? So obviously one pointer will keep here and one pointer will keep here, correct? And then we can do the scanning. Or what are the possibilities are there? Like let's suppose we'll take an index. Index is 0 1 2 3, means each index will keep, and will scan the arrays. Means we will scan both arrays words together, these words and this would, both words we will scan, right? And if the character matches, we will move from here to the next character. If not, we will increment the count. This is exactly what we are going to do. Okay, I'll repeat. What are the steps we will do, guys? The very first thing is that we scan both words together. Okay, you know how to do the two pointer algorithm, right? Then if the characters matches, right, it means we will move on, means we will increment the counter. Otherwise, if not, then we will increment mismatch or difference, whatever you will give the count. Mismatch count, you can say, mismatch that. So the moment the difference becomes more than 2, right, we will stop there. If the count becoming more than 2, immediately we'll stop, will not do anything, and we'll say this is not valid. This is what makes our solution efficient, guys. There is a big idea, don't overthink, and for every word, right, every query word, we can say, try to match it with the dictionary words that we have given here, right? And count the differences. If the count is less than equal to 2, accept it. Otherwise, stop it, discard it. That's it. There's no fancy data structures needed. Okay, let me show you how to implement it. So as I told you, we'll keep in the result set, so we'll take a result and finally we'll return the result, guys. Okay, now over the queries we have two things, queries and dictionary we have given. So query contains all the words. So let's suppose that word is nothing but q, will say that. So for each query, right, we'll go and we'll check into the difference, right, dictionary, right, and we'll find the difference. Okay, the very first thing that you check with the valid. If it is valid, means q and d are valid, means how many differences are there. If it is valid, right, it means we will keep in the result set, otherwise we'll not do anything, and then we'll break. We don't need to check further for these queries, same queries, right? So we'll create a valid method. It's a kind of helper function where we'll pass to array. Let's suppose this array A is word and this is wood, right, that we have seen that. Then we will say what? Okay, int difference will take how many differences are there for each query over the string A, means the query elements. Over the query elements, we'll check all the characters with the all the character with the dictionary. If it is not matching, we'll increment the difference. If the difference is greater than 2, we'll return false. We'll stop early, will not do anything. Otherwise, if the difference is matching, we will not go here because the character are all matching, so we'll return true. This way we'll find the valid and invalid things. That's all I have in this video, guys. So basically this line is a hero, right, of our solution, because early exist means early exist means faster solution, we can say that, right? And let me explain that what is the time and space complexity, guys. So let's suppose that this is query and this is dictionary, and both having some length, right? Let's suppose. Okay, so how many characters we are moving, right? Let's suppose the L is the length, right? Means we can say the time and space complexity. Let me write here. Let's suppose that I'm talking about the time complexity. Okay, and we have seen two things. What we have seen, guys? Let's suppose we'll take O of, for the query length, query words length, we'll take Q, and then multiply we'll do with the dictionary one, and both difference is nothing but L. So this is the space complexity, time complexity. And for the space complexity, we are only taking what do you call this result set, where we are storing that, right? So number of queries results that are valid, so that will be our space complexity. But I'll request you, if you can write the space complexity in the comment box, so I'll understand that you have understood the code, right? In case if you have any doubt, you can ask me in the comment box. But I'll suggest that this will become O of, we can say, as a 1 if we will exclude the output. Okay, because we are only storing there, right? If we'll exclude this part, output 1, so this will become O of 1, right? But I will want to understand that what you have understood from the space complexity. So that's very easy, guys. We have iterate over the queries, we have checked with the dictionary, right? So these two for loop is very important, because each character we have to check, right? Each words we have to check for each words, and each words from the dictionary you have to check that it is valid or not. If it is valid, add into the queue, otherwise don't do anything, right? And finally we'll return the result. For the valid one, we know that we'll check, we know that the length are same, right? In that case, what we will do, check the character difference. If there is no differences, right, will return true. If the differences there, count the differences and check the differences. If it is greater than 2, it is invalid. That's all we have done here. Thank you so much. I'll see you in the next one.